thermodynamics. So it is very important chapter according to for your NEET. And so everyone, am I audible clearly? Mamuna, Heba?
Yes, sir.
Okay, thank you. Now see, basically this thermodynamics, thermo that means thermal, you know, thermo that belongs to heat, and dynamic is in motion. So we just need to study about the motion of heat in physical as well as chemical process. So we are going to study about the motion of heat energy and heat in physical and chemical process. First of all, the most important terms that we use here is your system, then comes your surrounding. After surrounding, we have universe. Now, what is system? Basically, the container or anything in which you are carrying the reaction or the process, that is called your system. So let's say if you are making tea, so the container in which you are making, that container is your system, and just outside the system is your surrounding. Just outside the system is your surrounding. Just wait a minute. Now you are able to see this thing. So let's say if we have a container like this, and you are carrying a process, physical or chemical process in this container. So this container is your system, and just outside the system, like this is the boundary between system and surrounding. This is the boundary between system and surrounding, and just outside this is your surrounding. Now, what is universe? So basically, system plus surrounding together, they are universe. Is that clear, everyone? So this is how we understand about system, surrounding, and universe. Now, the most important point is that how many types of system are there? So system is of three types. System is of three types. The first one is open system. The second one is closed system, and the third one is isolated system. Isolated system. Now, the most important point here. What is open system? A system in which exchange of energy or heat energy, you can call heat energy, and mass with surrounding, between system and surrounding, between system and surrounding. So basically, it's very easy to understand any system in which mass or mass and this heat energy can be exchanged with system, can be exchanged between system and surrounding, that is known as your open system. Every process that is carried in a open container is your open system. Like if you are going to boil milk, and if this, the upper lid is open, and if you are going to boil it, you know the milk will evaporate. The mass or the matter of the milk will be evaporated in the surrounding. So this system is your open system. Now, what is closed system? Closed system is simple. It will be closed from all side, and here exchange of heat, between system and surrounding. So basically, any system which allows only heat to exchange between system and surrounding, that is called your closed system. There will be no exchange of matter between system and surrounding in closed system. When we are going to talk about the isolated system, neither heat nor matter or mass exchanged. Neither heat nor nor mass exchange between system and surrounding. Is that clear? One more important point here is that in closed system, the boundary or the wall is made up of what we call it basically diathermic. This is called diathermic wall or diathermic boundary. This diathermic wall has a quality that will allow only heat energy to pass through this, not matter. Whereas when we are going to talk about isolated system, it has adiabatic wall or boundary. And this adiabatic wall or boundary has a quality that does not allow either matter or neither matter nor heat to pass through this. So I think it's clear to you, right? Mamuna, Hiba.
Yes, sir.
Okay. Moving to the next topic. That is your types of thermodynamic properties. Types of thermodynamic properties. The first one is extensive property, and the second one is intensive property. Now see, what is extensive and what is intensive property? So it's very easy. Any property that depends upon mass or matter, you can say mass or size. So we can write mass dependent property, or at the place of mass we can use size as well, because size and mass are related. And here intensive, that means mass or size independent property. Let's say if we are going to talk about volume, so volume is an extensive property or intensive property. If you want to decide what you need to do, since either it will be mass dependent or size dependent, or either it will be mass independent or size independent. That means it will not depend upon size. If you are going to increase or decrease the size, the value will not be changed. But if you are sitting in a room of of volume, let's say 100 meter cube, and if you are going to divide this room into two parts, the value of the volume will be changed. That's why since the value changed, that means this volume is depending upon the size. That's why volume is extensive property. Is that clear?
Yes, sir.
Okay. Now you can see this is your intensive property. There is a room in which you are sitting, and the temperature of the room, let's say, is your 20 degrees centigrade. Now what you are going to do, just going to divide this into two parts. Just take a partition bit from the midpoint of the room with the bed sheet or anything. So what do you think? Will the temperature of this part different from this part? Yes or no? We are talking about temperature. If you are sitting in a room,
No.
it will not change. Basically, the value of temperature or the temperature will not change. That suggests you that it is not depending upon the size of the room. That's why temperature is your intensive property. So the first criteria how you are going to recognize whether this properties is extensive or intensive. So you whatever is given, you just need to think, you just need to divide that and then think whether the value will change or not. Let's say if you have a container of 10 kg, let's say 10 kg. Now if you are going to divide this into two parts, will the value of each part change or other than 10 kg? Yes or no? if you are going to divide this in two equal part, the one value will be 5 kg and another value will be 5 kg. If you are going to divide into 1:1 ratio, if you are going to divide into 1:2 ratio, it will be divided accordingly. And you can see the value changes, and hence mass is also extensive property. Are you getting my point?
Yes, sir.
Okay. Now there are some rules from which you can easily decide which property is.
Sir, should we note it down?
Yeah, you should. Should I slide it up or more?
Yes, sir.
Okay, just let me know when you are done with this.
Done, sir.
Very good. Please do write it. Let me know when you are done with this.
Done, sir.
Very good. Now see, there are certain rules, or if you don't know the formula or if you don't know the quantity, basically not the quantity, then you can easily recognize whether it is extensive or intensive. So the first note for this is the property, as I already told you, the property which of the property which remains same or unchanged on division of the system into smaller parts. is called extensive. Wait a minute, intensive. It doesn't change. So if there will be question like which one of the following is intensive or extensive, you are going to divide that property. If it will change, then it is extensive. If it will not change, then it is intensive. Note 2. The ratio of two extensive property. The ratio of two extensive property is always intensive. Is always intensive. I'm going to take an example. As you can see, density. If I will ask you, do you know density is intensive or extensive? You are going to apply the formula of density. You know that density is equal to mass upon volume. And as I already proved that this is extensive, mass is extensive, which depends upon size or size. Volume is also extensive, which depends upon size. So this is the ratio of two extensive properties. So the density will be intensive. And as you know that if the density of water is 1 gram per ml, whether the water is 1 liter or whether the water is 1000 liter, the density will be 1 gram per liter. It will not change with the size or mass. Is that clear, everyone?
Yes, sir.
Please do write it. And the last note, which is also very, very important, and that is your a physical quantity any physical quantity defined as per unit mass or per unit volume or per unit area or per unit length any physical quantity is defined in this form will be your intensive. Very easy. Please do write it and then let me know. Let me know when you are done with this. Saif, are you done with this?
Yes, sir.
Okay. This is a question. Identify extensive E and intensive I. You just need to write in bracket whether it is E or I. Some of them I already give you an example. Please do it. I'm waiting. Don't send in chat box. I will be telling you. I will write the answer and then match it. By the way, Hanifa, A is your round. Let me know when you are done with this.
Done, sir.
Okay. Match your answer. Density is intensive. Temperature is also intensive. Mass is size dependent. Molarity, molarity will be intensive. Heat capacity, extensive. A specific heat capacity, intensive. Internal energy, enthalpy. Internal energy, enthalpy, entropy, and Gibbs free energy. These all depend upon the mass. So these all are extensive properties. The refractive index is intensive. Pressure has a formula, force per unit area. That's why it is intensive. Surface tension has a formula, that is force per unit length. Force per unit length. That's why it is also intensive. How many of this is your wrong, Seth?
About 5, sir.
Which one?
Heat capacity, specific heat capacity, enthalpy, entropy, and Gibbs energy.
Okay, see, heat capacity depends upon mass. Basically, if you are taking more and more mass, the heat capacity will increase with mass. But a specific heat is defined for a fixed mass. That's why it is intensive, and this is your extensive. Whereas internal energy, if you will see, there will be a formula Q plus W, and then comes your enthalpy. Enthalpy depends upon number of moles. Entropy also depends upon number of particles or moles. Gives free energy. Energy, more number of moles or particles, more energy. So these all are extensive property, and in this chapter we will only deal with these terms, which are very important. Refractive index, whether you are taking a small mirror, a small glass or big glass, both have same refractive index. Is that clear, everyone?
Yes.
Yes, sir.
Okay, I'm going to change the slide. Now see, there are two types of function. One is a state function, and another is path function. This is state function, that means which only depends upon initial and final state, or final position, final state. The function which only depends upon a state, basically the function which only depends on initial and final, that is your state function. Let's take an example with this. This is a graph I'm gonna draw between P and V, and the graph is something looks like this, this and this. There is, this is your curve, not like this. Okay, now again it becomes like that. Wait a minute, please. The graph is like this. Now see, this is your first path, this is your second path, and this is your third path. This point is PA and this point is PB. Now, if you want to calculate the delta P, change in pressure, if you want to calculate delta P, change in pressure, for path 1, it will be final pressure minus initial pressure. For second path, delta P is also equals to PB minus PA, because change, when we calculate change, final minus initial. So this will be the final. If you are going to choose from this will be your final and minus initial. Second path you can see, and again the same from the third path, delta P is equal to PB minus PA. Now you chose three different paths, but all of them have same value of change in pressure. That represents delta P is independent of path. That represents that P is a state function. Are you getting my point? It doesn't depend upon the path on which it covered. It only depends upon the initial and final state. Are you getting my point?
Yes, sir.
So example of this is very important and very easy. Pressure, temperature, volume, entropy, enthalpy, internal energy, and gives free energy. These are all representation, which is a state function. I'm going to write it here. You know, P pressure, T temperature, V volume. S is your entropy. H is your enthalpy. And U is your internal energy. And G is your gives free energy. Please do write. Then we will talk about path function, which that's simple, which depends upon initial and final as well as the path. Let me know when you are done with this. Are you done with this?
Done, sir.
Very good. Now see. Path function, very simple, which depends on initial and final as well as path. For example, heat and work done. Always remember that this work done is your path function and Q is your heat, which is also path function. Very easy. Let me know when you are done with this. Are you done with this?
Done, sir.
Okay. Now, the next topic is thermodynamic properties. Thermodynamic properties. See, the first, sorry, thermodynamic process, not properties. So the first thermodynamic process is your isothermal. What does this mean? Isothermal process. Can anyone tell me? You know that iso means same and thermal is heat. So basically any process in which temperature is constant, that represent the process is isothermal. Any process in which temperature is constant. Now, if temperature is constant, that means dt equals to 0. dt equals to 0. And hence also delta T is also equals to 0. What is this? This is your change in temperature, final minus initial, and dt equals to 0. That means a small difference in temperature. Now there is a statement, if delta T is equal to 0, then it must be isothermal process. It must be isothermal process. And if dt equals to 0, then it must be isothermal process. Let me know whether the statements are true or false. What do you think about the first one? What do you think about the second one? Any answer? Mamuna, Saif, Hiba, Alan, Farhat, and Hanifa.
Yes, sir.
Yeah. What do you think? If delta T equals to 0, is it necessary that the process is isothermal? Yes or no? True or false?
No.
Why no?
Like if two temperatures are equal, then also there will be 0. So
Yeah, actually, if you are carrying a process from this to this time, so delta T, that means delta T means T final minus T initial. That means temperature at here and temperature at here. That represents 0. So it is not necessary that temperature will be constant for this to this time. Are you getting my point? Delta T only represent temperature at final position and at initial position. It is not necessary that the temperature was constant uh, through whole process. That's why it must be isothermal process. It is wrong. It may or may not be isothermal process. But when we are going to talk about dt is the small difference that represents every small difference change in temperature. And this dt, if dt equals to 0, then it must be isothermal process. Are you getting my point, everyone? So this is true, this is false. Please do write it.
yes, sir.
Okay, now the most important point, graph. In this chapter, graph is also important for the different process. Since temperature is constant and you have studied it in states of matter, in which you have studied Boyle's law, and Boyle's law says that pressure inversely proportional to volume at constant temperature. Temperature is constant, as well as number of moles is also constant. Since in this process you can see temperature is constant, that represents it's an isothermal process. And accordingly, I'm going to plot a graph like this. In this chapter, we will have two graphs for each. The graph will be same, only the direction will be different. Now this is your P and this is your V. If you have remembered the graph, since it is inversely proportional, so the graph will be like this and this. Only the difference is this represents the direction downward and this represents the direction upward. Temperature is constant, that's why it is isothermal process, and we plotted the graph like this, PV. Now this is called, since temperature is constant, it is isothermal, and you can see the volume is increasing with the time, so it will be known as isothermal expansion. And this is also temperature constant, so it is isothermal. And you can see the volume is decreasing, and hence it will be known as isothermal compression. Is that clear?
Yes, sir.
Please do write it. You are going to plot a graph for this. The graphs are similar, and the graph is in between volume versus temperature. You need to draw a graph for isothermal. And I think you can do this easily. Are you done with this? I say it's very easy. The graph between V and T. As you know, the temperature is constant, so you just need to draw it. You just need to make it a constant. Temperature is constant. So we can draw a graph like this. Temperature is constant. You can see. In the same way, you can go for another one. Temperature is constant. The graph will be similar. Only you need to draw the direction. This will be upward. This will be downward. Now, since temperature is constant, it is isothermal. And you can see volume is increasing, so it will be expansive. Temperature is constant, so isothermal. Volume is decreasing, so it will be compressive. Are you getting my point? Saif, Mamuna, Hanifa,
Yes, sir.
Eva, Alan. Can I change this slide?
Yes, sir.
Now the next process is your isochoric process. Isochoric process. You know what is isochoric process? Isochoric process is the one in which volume is constant. If volume is constant, that means dV will be 0 and hence delta V is also equals to 0. Same concept applied here as well. If delta V equals to 0, it is not necessary that it is isochoric process. But if dV is equal to 0, then it is necessary that it is an isochoric process. Now, you need to plot some graph for this, and you know that from states of matter. That is, wait a minute. Gay-Lussac's law. Gay-Lussac's law. What does it say? Pressure directly proportional to temperature at constant volume and number of moles. We only need to see this constant volume. So you are going to plot a graph, and please do it. We need to plot a graph for P versus T. Wait a minute. See. Are you able to see the screen? P versus T. The graph is P versus T. So you can see at constant volume, that means it represents isochoric process and pressure is directly proportional to temperature. So the graph will be like this, simple as that. The one, this will be like this and this will be like this. Now, since volume is constant, so we cannot write expansion and compression. Expansion, that means volume is increasing, and compression, that means volume is decreasing. And here the volume is constant, so it will not neither increase nor decrease. So what term we are going to use is your heating or cooling. Heating or cooling. Since volume is constant, so this is your isochoric, and since temperature is increasing, so this will be known as isochoric heating. And in the same way, this is your temperature is decreasing, so we can write isochoric cooling. Is that clear?
Yes, sir.
Thank you. Now you are going to plot a graph between this sentence, and that is your V versus T and V versus T for isochoric process. Ah. Let me know when you are done with this. Are you done with this? Now see, it shouldn't take this much time actually. Volume is constant, so you just need to do volume constant. Very simple. And in the same way, you are going to do for this. After a certain time, volume is constant. Now you can see, since volume is constant, this is your isochoric, and temperature, you can see temperature is increasing, so isochoric heating. And here again, isochoric, temperature is increasing. That means temperature is here increasing and here decreasing. So it will be isochoric. Are you getting my point? Yes or no?
Yes, sir.
Okay, please do write it. After this, we have again two graph, and after this, we have three more process, which is quite easy. Let me know when you are
Done,
done
sir.
with this. Okay. Again, I'm going to give you a graph for this, and the graph is very easy. The graph is between P versus V. The graph is between P versus V. So this is your P, this is your V, this is your P, this is your V. Now please do draw the graph for isochoric process. You know what is isochoric process, right?
Done, sir.
The graph is quite easy. You can see volume is constant, so you just need to draw a vertical line from that constant, that is your volume. And you just need to do one more thing, that is increasing, decreasing. Now see, this is your isochoric as the volume is constant, but heating or cooling, expansion and compression cannot be there because volume is constant. So heating or cooling, how we are going to decide? You know that pressure directly proportional to temperature. And this is Gay-Lussac's law. So you can see the pressure is decreasing, and hence if pressure is decreasing, temperature is also decreasing. So this graph is isochoric cooling. And in the same way, you can see volume is constant, that is isochoric. And here pressure is increasing, that means temperature is increasing, and hence isochoric heating it is. Please do write it. Are you done with this? Chef Mamuna Hanif, are you done with this?
Yes, sir.
Okay. The next process is your isobaric process. Do you know bar is the unit of pressure? So you can remember it from like this bar. And in isobaric, there is bar term. So in this, pressure is constant. And if pressure is constant, that represents dp is equal to 0 and hence also delta T is equal to 0. Now you know that V directly proportional to T according to Charles' law. Charles' law. At constant pressure and number of moles, we just need to focus on constant pressure. So that is why it is an isobaric process, and accordingly we can draw a graph to understand expansion and compression as well. This is the first graph and this is the second graph, and it's very easy. The graph is in between V and T, and the graph is between V and T. You know, volume directly proportional to temperature. That means it is directly proportional. So the graph will be like this. And again, the graph will be like this. But here we need to uh, show the direction as well. Now, since pressure is constant, so it will be isobaric. And in this, you can see volume is increasing, so it will be expansive. And here, isobaric, volume is decreasing, so it will be compressive. Is that clear to you, everyone? Now I'm going to give a graph for you that is between P versus V. The graph is for P versus V, and you need to plot it for isobaric. I think you can do this. In the next class, that means tomorrow, we are going to do important numericals. Or let me know when you are done with this. You can see isobaric pressure in which pressure is constant. So you just need to do this. Again, you just need to do this. And you can see this is your isobaric since pressure is constant and volume is increasing. So it will be isobaric expansion. And here again, pressure is constant. So it is isobaric and volume is decreasing. So it will be compression. I think it's clear to all of you, right? Is that clear, everyone?
Yes, sir.
Very good. Now, the next process is your adiabatic process. Adiabatic process. What is adiabatic process? So any process in which there is no exchange of heat, even heat, that process is known as adiabatic process. And in this process, Q will be equal to 0 because there is no heat exchange, and hence dq or delta Q both are 0. Very important. As you have seen in isolated system, the wall or boundary is made up of adiabatic wall, which does not allow heat to pass through this, and hence Q will be 0 and delta Q and dq will be 0 as well. The next process is your cyclic process. Cyclic process is very easy to understand. Cyclic process is the one in which wherever process is started, it will end at that place. Now let's see, there is a process like this. This is your A, B, C, D, and this is versus P versus B. Now it started from A goes to B, then goes to C, then goes to D, and again D to A. This type of process, a process which start from a point and ends at the same point following through series of steps, that type of process is known as cyclic process. Are you getting my point? And most important point from this cyclic process is that the value of a state function, the change in a state function like delta H, delta T, delta U, delta G, the value of this in cyclic process is 0. Are you getting my point? In cyclic process, the change in this, like you can take delta V as well, delta P as well. The value of change in a state function in cyclic process will always be 0. There will be direct question. What will be the value of delta H in the following graph? So if you understand that it is talking about a cyclic process from where it has started, it ended at that point following through series of steps. So the value will be 0. Directly you can answer that. Is that clear? Please do write it. Are you done with this?
Yes, sir.
Very good. Now see. There are two more processes which is very important, and that is, you already know that, reversible and irreversible process. First of all, this reversible process is very, very slow. Very, very slow. And this irreversible process is fast. Very easy to understand. And in this process, we are going to calculate the formula of work done. For reversible process, work done is equal to minus 2.303 nRT log of V2 upon V1 if volume is given, or either you can apply 2.303 nRT log P1 by P2. And in the same way, irreversible process has a formula, that is W is equal to minus P external into delta V. Delta V is the change in volume. Like we can also write P external into V final minus V initial, or in some books you will see V2 minus V1, that represents change in volume. So it's very easy. Now, how you are going to recognize whether which formula will be used? So if you know the process, what is the process where it is reversible and irreversible process, then you can easily apply. But For sure, in irreversible process, in the question, it will be given that external pressure is constant. Whenever this term, you will look at this term, external pressure is constant or external pressure constant, then that says that it is irreversible process, and hence to calculate work done, we are going to use these formulas. But if this is not given, that means it is a reversible process, and accordingly, we will use these formulas. Is that clear, everyone? Please do respond.
Yes, sir.
Okay. So how are you all feeling about the paper that is on Sunday, right? First of all, you are going to write this formula and then write the question and let me know the answer. Are you done with the question?
One minute, sir.
Oh, very good. Anifa, go for the question number 4. Safe, any answer? Very good. So, oh, wait a minute. I'm gonna ask Alan. No answer from you. Okay. See, you can see an ideal gas expands isothermally. That means temperature is constant from this to this at 300 K against a constant external pressure. That means irreversible. And for irreversible, you know that P external into delta V. Now, P external is what you can see the what happened. Oh, wait a minute. So for P external, you can see the pressure is given as 10 raised to the power 5 nanometer per square, nano per meter square. So 10 raised to the power 5 into what is the final volume? That is 10 raised to the power minus 2. What is the initial value? 10 raised to the power minus 3. Now, how you are going to solve it? It's very simple. If I'm going to take 10 raised to the power minus 3 as common, here it will be 10 and here it will be 1. So now if you are going to solve it, it will be 10 raised to the power minus 2 and minus is there in the formula that I forgot to write. And if you are going to solve this, there will be 10 raised to the power 2 and 10 minus 1, that is 9. So 9 into 10 raised to the power 2, that is 900 joule. So this will be the work done in irreversible of this process. Please do write it. Will you be able to solve question number 4?
Yes, sir.
It's also very easy. Against a constant external pressure of 2 bar, it's very simple. W is equal to again minus P external delta V. And you can see minus PP is what? Under isothermal condition, a gas at 300 expand from this to 2 bar pressure. And final volume is 0.25 minus initial volume is 0.1. Okay. So if you are going to solve it, you will be getting 2 into 0.15. And if you are going to again solve it, you will be getting 0.30 liter bar in negative. And if you are going to convert this 0.3 into 100, that will be minus 30 joule is your answer. Not plus 30. Very good. Is that clear, everyone? Alan, no response. Mamuna, Hanifa, Hiba,
No,
and
sir.
Farha. Okay. Can I change the slide? See, in the
Yes, sir.
next class, that means tomorrow, what you need to do is internal energy. Then comes your enthalpy. Then comes your entropy. At last, it will be, and there will be very less theory about Gibbs free energy, Gibbs energy. So in the next class, you will be reading about this from your notes or book. Then it will be very easy for you. So if we are going for internal energy, that represents basically the energy of the system, total energy of the system. And you know, if we are talking about if we are taking our body as a system and we are talking about the internal energy of our body or the system, there is a lot type of, there is very what we say, there are many kinds of energy in our body, like electrostatic energy, potential energy, kinetic energy, chemical energy. Lots of energy is there. So we will not be able to calculate the absolute. We cannot calculate, can't calculate absolute internal energy, but we can calculate change in internal energy. What was the initial internal energy of the system and final, and then easily we can calculate this delta U. First of all, this delta U is your state function, as I told you, and also this is your extensive property. So this is, you are not going to forget it. And from here we will get first law of thermodynamics. First law of thermodynamics. What does it say? What does first law of thermodynamics says? So it's very easy. Change in internal energy will be equal to Q plus W. Change in internal energy will be equal to Q plus W. If you remember, Q was a path function and W is also path function. But if you are going to add them, you will get another quantity, that is delta U, and this delta U is your state function. Or you can call it, when you are going to sum it, you will get a state function. So this is very important. When they are individual, separately, they are path function. But when you are going to add them, you will get a state function. And this is your first law of thermodynamics, which is based upon conservation of energy. Conservation of energy. So please do write up to this. Are you done with this?
1 minute, sir.
Done, sir.
Yes, sir.
Okay, so this is it for today. In the next